Today we're going to go over 3.2, perfect squares and perfect cubes. So today you will solve equations with square roots and cubed roots. So you're going to look for and make use of structure and attend to precision when you solve equations with square roots and cubed roots. A number multiplied by itself 2 times creates a perfect square. When the square root of a perfect square is evaluated, a whole number is returned. So let's go ahead and list the first 10 perfect squares. It's very important that you know these. So 1 squared is 1 times 1, which is 1. 2 squared is 2 times 2, which is 4. 3 squared is 3 times 3, which is 9. 4 squared is 4 times 4, which is 16. 5 squared is 5 times 5, which is 25. 6 squared is 6 times 6, which is 36. 7 squared is 7 times 7, which is 49. 8 squared is 8 times 8, which is 64. 9 squared, 9 times 9, which is 81. And then 10 squared is 10 times 10, which is 100. When you have a quadratic equation, so that means you have an x squared, or it might be a different variable. So it might be a squared or b squared or something like that. You're going to have 2 answers. So when you take the square root of that variable to solve the equation, you have to make that answer both positive and negative. And then you're going to write that as plus or minus, which is this symbol right here. So the reason you do this is because when you square a positive number, that answer is positive. But also when you square that negative number, the answer is positive. So take positive 2 and negative 2, for example. Positive 2 squared is 4. Negative 2 squared is 4 also. So those would both be options that you could plug in for x to find x squared. So let's practice this just a couple times. Let's go ahead and solve the equation x squared minus 5 equals 20. So the first thing we want to do, we want to isolate that variable. So we need to add that 5 to both sides to get x squared by itself. The minus 5 and plus 5 cancel each other out. So we're left with x squared equals 25. Now we want to get x by itself. We don't want x squared. So in order to get rid of that squared, we need to take the square root. The square root and that squared are going to end up canceling each other out to leave us with x. But before that, we need to make sure we take the square root of the right side of this equation also. Remember, even when we're square rooting, whatever we do to one side of the equation, we have to do to the other. So on the left side, the square root and the square cancel each other out. So we're left with x. And then the square root of 25 is 5. But remember, we're taking the square root, so we need the plus or minus in front of it. So we can always double check this. So if we plug 5 in for x right on the last line there, 5 squared is equal to 25. If we plug in negative 5, then negative 5 squared is also 25. So both those answers are options. So we need to make sure we give every possible option to make this statement true. So let's try this again. Let's try this with 2 plus 4x squared equals 146. So the first thing we need to do, just like solving any other regular equation, is we need to subtract the 2 from both sides. So the 2 minus 2 will cancel out, and I'm left with 4x on the left side and 144 on the right side. I'm going to divide the 4 so that I can get x squared by itself. So I'm left with x squared equals 144 divided by 4, which is 36. I want to get x by itself, so I'm going to take the square root of x squared And then remember, I need to do that to the other side of the equation as well. The square root and the square cancel each other out. So I'm left with x. The square root of 36 is 6. And then since I took the square root, I need that plus or minus sign in front of the 6. So if we plug positive 6 and negative 6 in for x, both of those numbers will work to make this a true equation, true statement. All right, moving on from perfect squares, we're now going to move on to perfect cubes. So now we're taking a number and multiplying it by itself 3 times, which creates a perfect cube. When the cube root of a perfect cube is evaluated, a whole number is returned, just like with perfect squares. But instead of taking the square root, now we're taking the cubed root. Let's go ahead and list the first 10 perfect cubes. It's also important that you know these. 1 cubed is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 times 2, which is 8. 3 cubed is 3 times 3 times 3, which is 27. 4 cubed is 4 times 4 times 4, which is 64. 5 cubed is 5 times 5 times 5, which is 125. 6 cubed is 6 times 6 times 6, which is 216. 7 cubed is 7 times 7 times 7, which is 343. 8 cubed is 8 times 8 times 8, which is 512. 9 cubed, 9 times 9 times 9, which is 729. And 10 cubed is 10 times 10 times 10, which is 1000. So when you have a cubic equation, so now instead of having x squared, we're going to have x cubed in the equation. We're only going to have one answer. So now, when you take the cubed root to solve an equation, you need to make that answer the same sign. So before, when we took the square root, we had to make our answer positive and negative, but now we're just sticking with the sign. So let's try this out to kind of get a better understanding of what I just said. So let's go ahead and solve c to the third plus 25 equals 241. So the first thing you need to notice is we have a perfect cube here. We have a third power. We want to get c by itself, so we need to subtract the 25 from both sides of the equation. 25 minus 25 cancels out, so I'm left with c cubed equals 216. 216 is a perfect cube. So now when I take the cubed root of c cubed, which looks like this, it's a square root sign and it has a little 3 up at the top of it. The cubed root and that third power cancel each other out, so I'm going to be left with c. But remember, I need to do that to the other side of the equation also. So I'm left with c equals 6. So 216 is positive, so my answer is going to be positive. That's what I was saying before when you have to take the same sign. So my solution to this problem is c equals 6. That's the only number that you could substitute back in for c to make this a true equation. Let's do another one. 4r cubed minus 133 equals negative 3049. The first thing I need to do is add 133 to both sides of the equation. My negative 133 plus 133 cancel each other out. So on the left side of the equation, I have 4r cubed, and on the right side of the equation, I have negative 2,916. I want r cubed, so I'm going to divide 4 from both sides of the equation. So I get r cubed equals negative 729. I'm going to take the cubed root to cancel out that cubed. So I need to do it to both sides of this equation. So on the left side, I'm left with just r, and on the right side, the cubed root of 729 is 9, because 9 cubed equals 729. And then that 729 is negative, so my answer is going to be negative. Let's work out one more problem. So now we need to find the length of one side of a square that has an area of 81 square yards. So let's go ahead and get a visual first before we work this out. We have a square, the area is 81 yards squared. And so thinking about this, if we want to find this length of one side and we know the area, well, how are we going to figure that out? I know that the area is equal to the length of one side times the length of one side of a square. Since those are the same lengths, I can say the area is equal to the length of one side squared. So S is equal to the length of one side of the square. And so now I know my area is 81, so I'm going to go ahead and substitute that in for A. So I have 81 is equal to S squared. I want to find the length of one side, so I'm going to take the square root of both sides of this equation. And so in a normal equation like this, I'm going to get S is equal to plus or minus 9. Because the square root of 81 is 9. We took the square root, so we need to take the positive and negative. But we need to think about what this problem is asking us. It's asking us for the length of one side of the square. We cannot have a negative length. There's no way. The smallest amount of length you can ever have is 0. It can never go negative. So negative isn't even an option here. So I can go ahead and say that the length of one side of the square is 9 yards. And that's it. You're now ready to work on your homework, which is due tomorrow, Tuesday, in class. If you have any other questions, feel free to send me a message in Canvas or come in during Advisor or in the morning before school.